Right, the keywords here, the keywords are to use appropriate substitutions, right? So meaning that you cannot actually use what we have learned to solve question 7C, right? Where you can actually express the left hand side and the right hand side, having the same base, right? Here you can actually express all to base 3, but there is no such a rule, okay? We don't have a to the power m minus a to the power n, right? There's no such a rule. Okay, if you were to recall, we only have rules for a to the power of m times, right? The operation must be a multiplication, right? Then you can add the power, or if we have the operation as a division, then you can actually take m minus n, right? So we don't have a to the power of m minus a to the power n. We don't have a rule for that. We also do not have a rule for a to the power m plus a to the power n. Okay, we don't have a rule for that, right? So these are the things that you have to remember clearly. All right, you must understand the rule well, then apply them correctly. Okay, so what we need to do here is we still have to express all as base 3. Okay, so square root 9. Now if you were to recall, I always advise you to work out whatever that's inside the bracket. All right, work out whatever that's inside the bracket, right? So square root 9 means 3 to the, square root 9 will give you 3, right? Square root 9 will be 3. And then this guy here, right? If you have a to the power of m plus n, you can actually separate them into a to the power of m times a to the power of n, right? So I can separate it into 3 to the power of x times 3 to the power of 2. Okay, it is not necessary to express 9 as 3 squared. Okay, it's not necessary, right? Because what we're going to substitute later on is 3 to the power of x to be substitute 3 to the power x to use another alphabet to represent it. Okay, so 9 not necessary to write as 3 squared. Okay, but 3 to the power of 2x, 3 to the power of 2x, we can actually rewrite it as 3 to the power of x, then bracket squared. Okay, or you can, if you don't like it, you can even write it as 3 to the power x times 3 to the power x. Because 3 to the power x times 3 to the power x will give you 3 to the power of x plus x. That will be 3 to the power of 2x. So whichever way you want to do, okay? As long as you apply the rules correctly. So here, what I'm going to do is, I'm just going to substitute, okay? Substitute this guy here, that I boxed it up for you. Substitute this guy with the letter U, right? So I'm going to say let 3 to the power x equals to the letter U, right? So I would end up getting U squared. Okay, I think I would use black color. Red is too glaring. I'll get U squared minus 9U equals to U minus 9. So again, you will see that I end up having a quadratic equation where I can factorize it, simple factorization. Okay. Right, we'll continue at the next slide. Continue our mission of solving the questions. Right, so this can be easily factorized into, oh, I'm not getting the correct, okay, into U minus 9, then bracket U minus 1. All right, so if you apply the zero product rule, that gives you U minus 9 equals to 0, or U minus 1 equals to 0. So U is equals to 9, or U is equals to 1. Right. So do recall that we are solving exponential equations involving x, and U is not the final answer that we are looking at. The answers that we are looking at are the values for x. So hence, I have to substitute u with the substituted value that I used earlier on, which is 3 to the power of x. So u is actually 3 to the power of x. So 3 to the power of x equals to 9. And 9 can be written as 3 squared. Hence, x equals to 2 is one answer. Likewise, for u equals to 1, that will be 3 to the power of x equals to 1. Right, recall that you can actually write 1 as a to the power of 0. Right, it means 3 to the power of 0 is 1, 4 to the power of 0 is 1, etc. Okay, so 3 to the power of x will be equals to 3 to the power of 0. So x equals to 0 is another answer.